This is a C4 section B question on vectors. There are 2 questions in section B, each one's worth 18 marks. In this question, it's about a coal seam, although when you look at the diagram, you may well just see a couple of triangles. It's worth just trying to picture the situation of what's going on, rather than just seeing a couple of shapes. So we've got A, B, C and D, E, F, which are appearing to be kind of triangles, but we're given that the axes, we've got OX is due east, so we've got east, and then we've got OY to the north, and we've got OZ going vertically upwards. And this is all about a coal seam. You might not know much about coal. It's made by trees, which eventually, under lots of intense pressure, become coal. And what we've got then is this seam of coal that's in between these 2 layers. Now we can see from the diagram that the 2 layers are not actually parallel, and neither of them seems to be parallel to the XY plane. But the fact that they are on the negative Z axis tells us that this coal seam is definitely underground. Ground level would be the XY plane. So we're given the coordinates of all the points involved in this question, and we're going to have to find the Cartesian equation of the plane, but it's just verify, so that should mean that we can just substitute some values in. Very little calculation should be needed here. We're then going to find vectors DE and DF. Again, that should be relatively straightforward, and then show that a vector is perpendicular to each of these, so that'll be using dot product equals 0, and hence find the Cartesian equation of the plane. So if we've got a vector perpendicular to both of these, and they're in the plane DEF, then we'll be looking for the normal vector to be this vector here, and we'll just need to find the other point in our equation of the plane. We're going to calculate the angle between the normal vectors of the 2 planes and find the angle between the planes using that. So that'll be just using the A dot B over mod A mod B thing. Okay, and then we're going to drill down to a point in a line perpendicular to the upper surface of the seam. So not a vertical drill, but going in perpendicular to that upper surface, so in the normal direction to the upper surface. And that's going to meet the plane ABC at a particular point. We'll be looking at the equation of the line that the drill's on and calculating the coordinates of the intersection of that line and the plane. The first part is relatively straightforward. We just need to show that the coordinates actually fit the equation of the plane. So we do 3 multiplied by the x coordinate plus 2 multiplied by the y coordinate plus 20 multiplied by the z coordinate plus 300, and we should get 0 for each of the points. So if we go ahead and do this, for the point A we get 3 multiplied by 0 plus 2 multiplied by 0 plus 20 multiplied by minus 15 plus 300, which gives us minus 300 plus 300, which is 0. So that means that A lies on the plane. We do the same thing for point B, checking that its coordinates fit the equation. We do get 0, and we do the same thing again with the point C. So that's all we need to do for this part of the question. So in part 2 we're going to find a couple of vectors. We should write down the coordinates of the points as position vectors. So the coordinates of D, which were 0, 0, 40, become the position vector 0, 0, minus 40. Okay, so we want to find the vector DE. We need to make sure we get this the correct way round. So to get the DE vector, we use E minus D in the opposite order from the order that the letters are written. So if we do E minus D, that's 100, 0, minus 50, and then we subtract 0, 0, minus 40. As with any exam question, be extra careful with things like this. We've got minus 50 minus minus 40, so that's minus 50 plus 40. Be careful with these, it's a very common place for mistakes to be made. So that gives us 100, 0, minus 10 for the for the vector DE. Okay, so then we do the same sort of thing for DF. This time it'll be F minus D, so we do the vector F minus the vector D, and that gives us 0, 100, 5. So the important thing here is to subtract in the correct order and to make sure that we actually write the two vectors as vectors and not as coordinates. So then we need to show that these vectors are perpendicular to a particular vector, and we know the scalar product is 0 for perpendicular vectors because if we do a dot b over mod a mod b we get cos theta, and when they're perpendicular that's cos 90, which is 0, so the numerator, the a dot b, that part must be 0. So if we do the vector DE dotted with the vector 2 minus 120, then we end up with 0, so that tells us that DE is indeed perpendicular to 2 minus 120. We can do the same thing for the vector DF and do the dot product of that with the vector we were given, and again we get 0. So that means that 2i minus j plus 20k is perpendicular to both. You could stick with i's, j's and k's in these questions, but it's usually easier to rewrite the 2i minus j plus 20k in the column vector form. So since DE and DF both lie in the plane, then that vector that we were just using is normal to the whole plane. So we can use the equation r dot n minus a dot n equals 0. The r here is the general vector xyz. So when we dot that with n, we'll get 2x minus y plus 20z, and then the a dot n is where a is the position vector of any point in the plane. I've chosen to use point D, or the position vector of point D, for my a, which gives me an a dot n value of minus 800. When I put this into the equation, we get 2x minus y plus 20z equals minus 800. In part 3 we go on to find the angle between the planes using the angle between the normal vectors. We can use the coefficients of x, y and z for the normal vector to the plane ABC. So that means we've got a normal vector of 3, 2, 20. So the angle between the normals is given by the dot product formula that cos theta is the dot product of the two vectors divided by the modulus of the two vectors multiplied together. So if we evaluate the parts, we get the dot product in the numerator, which is 3 multiplied by 2 plus 2 multiplied by minus 1 plus 20 multiplied by 20, and that gives us 404. Then in the denominator we use Pythagoras, which works in 3D quite nicely, and we get that the modulus for 3 to 20 is 3 squared plus 2 squared plus 20 squared, square rooted, root 413, and similarly for the other vector we get root 405. So theta is the inverse cos of 404 over the square root of the product of 413 and 405. We can put that into the calculator. That gives us 8.95 degrees. We should round our answers, and it's usual to round to 3 significant figures and state that we've done that in our answer. In part 4, we've been told that the line RS is perpendicular to the plane ABC. So we know that the normal to the plane 3, 2, 20 is going to be our direction vector for RS. Now the equation of a line is a point on the line plus a multiple of the direction vector. So we can use the point 15340, which is r, plus a multiple of that direction vector. We know that S lies on this line, so the coordinates of S will fit this pattern, that the x coordinate is 15 plus 3 lambda, and similarly the y coordinate is 34 plus 2 lambda, and the z coordinate is 20 lambda, or 0 plus 20 lambda. So if we substitute those into the plane, we have 3 multiplied by the x coordinate, so that's 3 multiplied by 15 plus 3 lambda, and then we add on 2y, so that's 2 multiplied by 34 plus 2 lambda, and we add on 20z, so that's 20 multiplied by 20 lambda, plus 300 equals 0. That was the equation of the plane with these coordinates substituted into it. We now just solve this equation for lambda. Be very careful. Take as many lines in the working as you need to ensure that you accurately calculate lambda. It's very common for people in C4 to be able to do the complicated things and make a mistake when multiplying 3 by 15, for example. You can type these into your calculator if need be, whichever way works for you. So then we've got lambda is -1 and we want the coordinates of S. So we can substitute in -1 into lambda. So we've got 15 minus 3, 34 minus 2 and 0 minus 20, which will give us 12, 32 minus 20, which we need to write as coordinates because the question did ask for coordinates. The mark scheme is here if you want to pause the video to take a look and see what's there in terms of how many marks you get. And these are the last two parts in the mark scheme.